shift from a monolithic application to microservices architecture is one of the most talked about transitions in enterprise software today, and for good reason. It promises agility, scalability, and faster time to market. But it is also one of the most complex moves you can make, one that's often underestimated. In this video, I'll walk through the first practical steps of breaking down a monolith, how to manage communication between services, and how to avoid some of the common pitfalls like service sprawl and operational overload. Breaking apart a monolith starts with understanding what you have. That means mapping out the existing system, its modules, data flows, and dependencies. We use tools like static code analyzers, dependency graphs, and architecture design records to capture this baseline. Once you've done that, you look for logical seams in your application. Ask, what modules are already loosely coupled? What features could safely live on their own? Some good first candidates include authentication and authorization, as they are often stateless and externally integratable. Email or notification services are also a good choice, as they are typically event-driven and low risk. Also consider reporting or analytics engines, as they can run on replicated data and don't need real-time integration. These are often less entangled with core business logic and can be extracted with minimal impact. We typically use a Strangler fig pattern when new microservices are layered over the old system, letting the monolith shrink over time without a risky big bang rewrite. You might also wrap monolith components with a Facade API, so both legacy and modern pieces can safely live side by side. Once services are split out, they need to talk to each other. That's where inter-service communication comes in. There are two main models, synchronous and asynchronous. Synchronous communication means one service calls another directly, usually over HTTP or RPC. It's straightforward, but it also introduces tight coupling, and if a service goes down, it can cause cascading failures. With synchronous messaging, you will also need timeouts, circuit breakers, and retry logic to build resilience. Switching gears to the other model, asynchronous communication, it's when you use message brokers like Kafka, RabbitMQ, or Azure Service Bus. It decouples services and boosts scalability, but it adds complexity. You'll need to handle event schemas, dead letter queues, and eventually consistency. Either way, you need to build for failure. For both models, make sure services are idempotent and use correlation IDs for distributed tracing. This keeps things observable and debuggable in production. One of the biggest risks with microservices is going too far too fast. Not every function needs to be its own service. Splitting too much too soon creates overhead, more deployments, more monitoring, more complexity. To avoid that, we recommend starting with domain-driven design. Group related functionality into bounded contexts and let those guide your service boundaries. For example, instead of splitting user management into 5 microservices, create one solid user management service. Tools that can help include API gateways like Kong or Azure API Management, service catalogs like Backstage, and observability tools like OpenTelemetry or Jaeger. These can help keep things organized and observable as your system grows. The goal isn't to have micro-sized services, it is to have right-sized services that align with your domain and teams. Moving from a monolith to microservices isn't just a tech decision, it's an architectural and organizational shift. Done well, it can make your systems more scalable, resilient, and easier to evolve. But it's not a silver bullet, and growing pains are real if you're not prepared. At Keyhole Software, we help teams plan these transitions with clarity and execute them without unnecessary complexity. If you're exploring this move and want experienced guidance, reach out to set up a free consultation. We'd love to help you build the future, one service at a time.